All right, let's talk about some operations on complex numbers, or you could say operations with complex numbers. Now, just so we're all on the same page, operating, we mean add, subtract, multiply, and we're not going to cover division. We can talk about division. Sometimes I'll do like a warm up where we'll just like address division, but the key things you want to be able to do with complex numbers are add, subtract, and multiply them. Now, first we want to define what is a complex number. In the last lesson, we introduced I as the imaginary number. And so now we've got this new vocabulary word for complex numbers. And sometimes those words are used interchangeably. They're not really the same thing. So an imaginary number is like I or for I. A complex number is something that's a little bit different. And then honestly, if we use them interchangeably, we're being kind of lazy about it. But a complex number has a real and an imaginary part. Okay, a real part and an imaginary part. And they're basically added together. Now, you might see it with subtraction, but remember that subtraction is just adding a negative, so we can say adding. And here's what it looks like. It takes the form a plus bi, where a is the real part, okay? So a real number like 1 or 2 or 1/2 or -3, okay? And then the bi is the imaginary part. All right, and that's pretty much what it is. So some examples of complex numbers. Examples of complex numbers could be something like 2 plus 3i, okay? And the 2 is the real part, and the 3i is the imaginary part. Now, just so we don't get too stuck in a rut, you could have, like, say, a decimal for one of them. So you could have 0.5, and it could be negative. So like 0.5 minus 2i, that would be a complex number. You could have I don't know, we could have a negative for the real part. So -3 plus 0.25i. Okay. But I think you get the idea. So you have a real part that would typically be on the left, and then you have an imaginary part that is typically on the right. When you are writing your answers, you do want to put them in that order. So if you're done with a problem and you end up with 3i minus 4, you would want to rewrite that as -4 plus 3i. So you'd want to switch the order to get it into the right form, and then make sure that you carry any signs with it. So the 4 there is negative, so you'd move it around. Okay, so that's what complex numbers are. And now we'll just go into like, how do I add them? How do I subtract them? How do I multiply them? Not how to divide them. Okay, so, all right, so let's go. So adding them. So here's the deal. The I is not a variable. So I know sometimes when you were talking about variables, we think of a variable is like a letter. Not quite. Like, a variable is represented with a letter, but a variable is actually like a letter that represents an unknown. And so if you have like 2x, like the x represents like some unknown number or some number that it could be like anything. Like, so maybe x is a 1, maybe x is a 2, maybe x is, okay. That's what a variable is. Now, the I is also a letter, but it's not a variable because, yeah, so if you see the I there, because I is equal to the square root of -1, right? So it's not a variable. It's not like I can be anything. I is the square root of -1. But here's the deal. It behaves like a variable when you are calculating with it. So if you can do 2 minus 3x plus 5 plus 6x and simplify that, then you can do the problem that we have here, because the I is going to behave like a variable. So let's go ahead and pull these apart. So now in this problem, the parentheses are what I call cosmetic. So the parentheses are there to set apart one complex number from the other complex number, but they're not performing any actual function. So think about like cosmetics, okay, like the word cosmetics, like, and if you think of what are cosmetics, their makeup. Okay, cosmetics is like another word for makeup. And I could like take my eyes here and I could put on like eyeshadow and mascara, eyeliner, could put on all the things. And it would change what my eyes look like, but it wouldn't change what my eyes do or how well they work. That's what I mean by the parentheses are cosmetic. They change the appearance of the problem, but they don't actually do anything. So when you're looking at the adding, you can literally just remove the parentheses. So 2 minus 3i plus 5 plus 6i. And then we do what's called combining the like terms. So you combine the real terms and you combine the imaginary terms, and that's all you do. So looking at this, we would do 2 plus 5. That would give us 7. And then we'd have negative 3i plus 6i, which would be 3i. And so the answer to that problem is 7 plus 3i. We have added them together. That's all there is to it. So now, some students prefer not to remove the parentheses. They just get a little annoyed, like, why do I have to rewrite that without the parentheses? That's really your call. I'm going to go ahead and remove them on this one. So negative 3 plus 2i plus negative 2 minus 5i. And if it helps to circle your like terms, do that. So negative 3 plus negative 2 is negative 5. And then we have 2i minus 5i, which is negative 3i. And make sure that there's no equal sign here. Okay, so you're not writing any pluses or minuses underneath. We're not doing any of that. We're just combining. Okay, so you're just adding or subtracting whatever the operation is. So for practice, go ahead and pause the video and work those problems out on your own. Take a couple minutes and do them out, and then you can unpause it and we'll check it. Okay, so I hope you took that moment to pause the video, and we can check this. And that mimics what we would do in class. So we're trying to mimic class as best we can. So in class, I put those up on the board, give you guys about 2 or 3 minutes to work on them on your own, start walking around, check and see how people do, answer some questions, and then go over them. So we have 1 minus 7i plus negative 4 minus 2i. And so I have 1 plus negative 4, which is negative 3, and negative 7i minus 2i, which is negative 9i. So we have negative 3 minus 9i is what we should have there. Okay, next one is 4 plus 2i plus 3 plus 10i. And we have 4 plus 3, which is 7. And then 2i plus 10i, which is 12i. So hopefully that went okay. Common mistakes are usually sign errors with the adding and the subtracting of the negatives. So that's usually what goes wrong. Now, if you're like, I understand the algebra, I understand like what a complex number is, I understand that I'm combining the like terms, but you're getting the wrong answer. You want to see, is that an arithmetic problem, and could you solve it just by using a calculator? Okay. All right. So subtracting. Now with subtracting, the parentheses are actually not cosmetic. Now they are indeed used to set apart them, but when we subtract the complex number, we are subtracting everything that's inside of it. So we're going to subtract the real part, which is the 5, but we also have to make sure we subtract the 7i, the imaginary part. So both parts have to be subtracted. When I remove the parentheses, I'll have 2 plus 2i minus 5 minus 7i. So right here down at the bottom, make sure to distribute the negative. Okay, make sure that that negative gets distributed all the way through. If you want to think of it as like a negative 1 that's being multiplied, and you're going to multiply that negative 1 through, that's a totally fine, good way to think about it. Then it's just like an adding problem. So we have 2 minus 5, which is negative 3. and 2i minus 7i, which is negative 5i. Okay, next one down, same thing. Okay, we want to make sure that we distribute that subtraction. So we have the negative 2 plus 3i, and now it's going to be minus negative 1. Now, just minus a negative 1, which is the same as plus 1. Whoops, didn't turn my pen back on. And then minus 2i. And now we'll combine our like terms. So negative 2 plus 1 is negative 1. And 3i minus 2i is 1i, or you could just say I. Okay, so as before, pause the video and work these two out on your own. Shouldn't take you more than 3 or 4 minutes maybe for both of them. I'm not sure. Go ahead and pause the video and then unpause it, and then we'll go over those together. All right. So here we have negative 2 minus 1i minus 4 plus 6i. Okay, now at this point, I will often have a student like ask me, so you flip the sign of everything in the second parenthesis. Yeah. Now, I don't really want you to think about that. Like what you're doing is you're subtracting, but mechanically what happens is, yes, you are subtracting or flipping the sign of everything in the second parenthesis. Negative 2 minus 4 is negative 6. And then negative 1i plus 6i is 5i. Okay, so that should be the answer to the first one. And the next one, we'll have 3 plus 2i minus 2 minus 4i. And combining like terms, we have 3 minus 2, which is 1, and 2i minus 4i, which is negative 2i. So, ta-da, yay. All right, on to the next thing. Okay, now for some reason, the title is not there. There it is. Okay, so multiplying complex numbers, and for this, we are going to use an area model. Now, we haven't really talked about an area model this year. So normally this lesson comes after we've done a lot with like factoring and stuff, and we're familiar with the area model. But basically the area model does look like a box, okay? But we want to think of it as base times height all the time. And you can put both complex numbers on either side. Ooh, there's an I missing in that one. Ooh, I edited this slide earlier, but that is not good. So that should be I don't want to put it there because it'll cramp out my answer there. That should be negative 1 plus 4i. There we go. Sorry about that. Negative 1 plus 4i. So, and then to multiply, you would basically multiply each of these like areas. So a base times a height. So negative 1 times 2 is negative 2. Negative 1 times 3i is negative 3i. 2 times 4i is 8i. And then 3i times 4i is 12i squared. Now, we want to combine like terms, but check this out. There are my like terms. So I have 8i minus 3i, or you could think of that as negative 3i plus 8i. So when I go to combine them, I have negative 2 plus 5i plus 12i squared. But looking down at the bottom, remember that I squared is equal to negative 1. That's one of our definitions from last class. So we can actually go further than that. So we have negative 2 plus 5i. This is 12 times negative 1 because I squared is equal to negative 1. So we have negative 2 plus 5i. 12 times negative 1 is negative 12. And now I have this like term here going on where I have negative 2 and negative 12. So negative 2 minus 12 is negative 14. And then we'll have the plus 5i. So my final answer to that would be negative 14 plus 5i. Now, the next one down is a little bit different. You can use an area model to do this. It would look something like this, where you would have negative 2 minus 4i times 3i, okay? Or you can just distribute, all right? And you actually have that option with the first one as well. You can FOIL, which is distribution. But negative 2 times 3i is negative 6i, and then 3i times negative 4i is negative 12i squared. And so for this one, we have negative 6i minus 12i squared. But remember that I squared is equal to negative 1. So we have negative 6i, negative 12 times negative 1 is positive 12. And then I kind of ran out of space there because I have that little reminder. So sorry about that. We're going to have to duck over here. You want to remember that you put it in the right order. So instead of the like imaginary part first, we're going to put the real part first. We're going to do 12 minus 6i, or you could say 12 plus negative 6i would be fine to put that in the final form. Okay, so a little bit more complicated than maybe you're used to. What is important to note there is that the I squared, when you get that I squared, that's equal to negative 1. So you actually have a little bit further you can go. All right, so a couple of ones to practice with. And as before, pause this video and try to do them out on your own. Don't be surprised if you make a mistake. Totally okay. Just try to do it. And then when you unpause the video, check my work with yours and see if we can get them to match. All right. Okay, so let's take a look at this first one. So if we do this with the area model, we have 2 plus I across the top and negative 2i on the side. So this would be negative 4i, and this would be negative 2i squared. Now, what a lot of students do, and which you are more than welcome to do, is when they go to rewrite this, they'll have negative 4i minus 2, and then we know that the I squared is negative 1. So unlike over here where I wrote out the I squared and then substituted it with a negative 1, and I did it here, wrote out the I squared and substitute with negative 1, when they do the rewrite, we'll say, okay, the I squared is equal to the negative 1, and they'll do that substitution there, which I think is totally fine. All right, and then we have negative 2 times negative 1, which is positive 2, and then it's out of order, so we want to change that to 2 minus 4i. Ta-da. Okay, next one. I'm going to do the area model up here where I have some space, and I have 3 plus 2i and 3 minus 2i, and 3 times 3 is 9. 2i times 3 is 6i. 3 times negative 2i is negative 6i, and negative 2 times positive 2 is negative 4, and then I times I is I squared. Now on this one, check it out. 6i minus 6i is 0. So we actually don't have a middle term on that one, and we'll end up with 9 minus 4. And right now you could write I squared, or you can remember, hey, I squared is equal to negative 1. Negative 4 times negative 1 is positive 4, and 9 plus 4 is 13. So you might have thought, oh man, I got that wrong. What happened to the I? Wasn't I supposed to have an I in the answer? Maybe not. Now, take a look at the original problem there. 3 plus 2i and 3 minus 2i are almost the same, except that one of them is positive and one of them is negative. So you want to follow that, just kind of make a little mental note in your brain. Okay. So that was the whole lesson. So that was less than 20 minutes. Now, if you pause the video like I asked you to, instead of 20 minutes, you might be more in the ballpark of 35, 40 minutes since you started the lesson. That's actually not bad if you're doing this to make up. Remember that you missed a what did you miss? Like a 90, 100-minute lesson, and you're making it up in like 40 minutes. So not bad. Now, the last thing here is the practice set. Perform the indicated operation. So before you launch into that, I want to call your attention to, well, what is the indicated operation? Sometimes students see all those parentheses and they're just like, I will multiply. I will multiply them all. I will multiply all the things because parentheses mean multiply. Maybe not. Look at the operator, okay? So this first one is subtraction. Second one is multiplication. The third one is multiplication. But the fourth one and the fifth one, we're back to subtraction. 6 and 7, just 6 and 7, not that other thing that people keep saying, are adding, okay? 8 goes back to multiplication, 9 is adding. And in 10, we have an amazing word problem, and I cannot seem to turn off my face. Cannot select camera mode during recording. So I think I would have had to have turned it off at the beginning. So, all right, in electric circuits, the voltage in the circuit is equal to the current times the resistance using the formula V equals IR. Okay, so voltage is equal to current times resistance. Current is represented by I. Don't ask me why. If the current I is 2 plus 3I, and amps, okay, that's just a unit for current, is amperes or amps, and the resistance is -3. I believe it's a plus 5I. I believe it's plus 5I that we've got out there. That's what I'm going with. All right, plus 5I. That's a 5. It's a terrible 5. I'm not sure I've made it any better. Definitely haven't made it better. There we go, 5I. What is the voltage? So you can absolutely do this. Like, you don't need to know anything about electricity or current or anything like that, okay, to be able to do this problem. All right, so there you go. If possible, have that done by the beginning of next class so that you can go over it. And you guys know where to find me if you have questions.